All right, definition of the definite integral. For problems 1 and 2, use the definition of the definite integral to evaluate the integral. Use the right endpoint of each interval for xi star. Okay, so I need to try to recall what the definition of the definite integral actually is. So I believe that it's this. And then we multiply the function by the width of the little tiny subintervals. And let's see. There's the width of the subintervals, right? That's going to stand for my dx. And then for f of x, well, that's some chosen point in the subinterval, right? I think. Now, let's see if I can do it. Okay, so the definite integral from 1 to 4 of 2x sub 3 dx. No, that should be. So first, let's just compute it like in advance, because we already know how to actually do this. Integrate. Four squared at 12, so 16 at 12, so 28. And then 1 at 9, so 10. We get 18, right? So we're expecting 18. So let's see if we can do it. I guess 4 minus 1, so I guess it would be 3 over n, right? And then, well, and then we would actually spell out the definition. So, and because of how I think, I'm going to have to divide it into 3 subintervals. So that would like go 1 to 2, 2 to 3, 3 to 4. And then it would be that from before. And then 2 lots of it. I guess there's 1 lot of it there. Yeah, I don't need to do the dot dot dots, but it's just letting me spot the pattern, or like see the pattern, or feel it, or get closer to how it works. So when you have the right endpoint, you end up multiplying it by I, don't you? And what do you actually multiply by? We do two times what? That right endpoint. No, here, this is actually wrong. Sorry about that. That's the width. The width is just 3 over n, and that makes sense. Okay, but here, you do 3i over n. You add 3. You times them out. Okay, so all right, so that's the limit as n approaches infinity of the sum of I equals 1 to n. So let's see. Okay, that'll be 6i over n plus 3. All of that is times by 3 over n, which is 18i over n squared plus 9 over n. So I think it's, I actually do think it is that. Like that. Kind of struggling to see how it can't be. And well, actually, I can combine those, can't I? 18i plus 9n over n squared. Like that. Not really too sure. Okay, total agreement that 3 over n is the width of the subintervals. And what do those subintervals look like? Well, they do start with 1, and it will be like that. Yeah, I agree. Okay, so what's actually wrong here? What's wrong is the right endpoint. The right endpoint is not 3I over n, okay? Because if you plug in 1 and 3 there, you do not get 2, you get 1. And therefore, there has to actually be a little plus 1 here. Like that. Okay, and now think about what that means. So it's going to be that. Well, I guess they don't want that combined, probably because they're going to say that this will surely disappear and this will surely not, somehow. Yeah, okay, so now what are they doing here? Well, first So just ignoring this whole saying, let's just suppose that n actually is fixed, right? Then we'll, split it up into a pair of sums as your with summation notation. All right, and because n is a fixed number, you can bring that out. You can also do that. Now we know that that's n times 15, and that's an nth of n times 15, so it's just literally 15. This here is not as straightforward. Wait. Was I aiming at the wrong thing? Plus divide by, plus 1 divide by. Alright, 4 squared, so 16, 12, so 28. Then you get 1 and 9. 1 and Of course it's wrong. Of course the arithmetic's wrong. Darn thing. Right, so that was fixing that. Right, I see it now. Okay, so the real way for me to see if I actually understand that is to do it all over again. It's true. Got to do it all over again. Because otherwise it's just, I mean, it's effectively just copying out someone else's work, isn't it? It's not really getting it. So That is the limit as n approaches infinity of the sum of I equals 1 to n of something, but we don't know what. We know that the difference between the upper and lower limit of the definite integral 3 will be divided by n. But what we want to do is we want to see what do the subintervals look like. So the leftmost one must start with 1. And the rightmost one must end with 4. Okay? Now, what does it look like? Now we're going to use the rightmost endpoint. Three I over n. All right, so I'm gonna just do that. Well, actually, I don't know. I haven't done these before, so so it will be 1, which is pleasant. But what do these subintervals look like? You start up with 0, comma. I don't know why I'm overthinking this. 1 over n, surely. 1 over n, 2 over n, and so on. Or just simply 1. And the rightmost endpoint is just I over n. So that's what I need to feed into that function there. So 6 times I over n times I over n minus 1. And let's multiply. This is playing the role of my dx, the discrete case. Okay, so do something with this. But do what? All right, so that, and that, put them together as 6i over n squared. Here, I take n over n. So it would look like this, I guess. All right. Now, consider that for a moment. Now, if n is discrete, I mean, if n is fixed, I can just bring that out, can't I? And I can bring out the 6. And here they cancel, so I bring out 6 over n squared, and sum from I equals 1 to n, just I. So, what is the formula for the sum of the squares? Well, this I tend to forget. Wait, again? I think it's something like n times n add 1 times 2n add 1 all over 6, something like that. Oh, yay. Okay. n times n add 1 times 2n add 1 all over 6. So perhaps we can do that. Sum of the first n numbers is just n times n add 1 over 2. Wait. Did you forget the 6? You did. So now they cancel, so that's good. So we are getting closer. So that'll be a 3. So what now? Something. Well, these cancel, don't they? Into squared. All right, now they have a common denominator at least. Okay, so why don't you clean up that? 2n squared take 3n squared. So minus n squared. 2n add n, so 3n. And then 3n take 3n is nothing. And then 1 just by itself. Well, this is a disaster, isn't it? You know what? Just see what it's going to be ahead of time. Okay. In case it actually is something like 0. So plus 1 and divide by. Plus 1 and divide by. 1 to 0. You sub in 1. You get minus 1. You sub in 0, you get nothing. So, okay, maybe it's not so bad. Maybe it's not so bad. Okay, now we go here. The limit to infinity of minus 1 plus 1 over n squared, which is minus 1. Okay, but does it look okay? Okay, those subintervals look all right. Right endpoint, I over n, that's good. All right, they use the formulas I did. Ish. Okay, that's just 0. Is 0 by that property of definite integrals. The integral of a to a, from a to a of f of x dx is 0, isn't it? All right. Okay, so now we're going to be looking more at properties of definite integrals. Okay, so the 9 can come outside, and that will be positive 7, so I think it's just simply 63. And for this one here, 6 times minus 10 times minus 7. So 144 plus 70, which is 240. That's right. Problem 6. Determine the value of the integral of x given that this and this. What do you do? You turn this one around and it becomes negative 3. And this one is 8. And then you have to add them together. And so you get 5. But I'm going to spell that out. That's right. That's right. 7. All right, so we are told these facts. And we have to find that integral right there. All right. From negative 4 to 20, f of x dx. Make that one negative. Take that one away. And then add on this. There. Plus the negative of this minus this. Wait. Okay, so that would be negative 2 plus negative 19. That really zero. Okay. Problems 8 and 9, sketch the graph of the integrand and use the area interpretation of the definite integral to determine the value of the integral. Okay, so we need graph paper. So go to GeoGebra here. And borrow some. 1 to 4 is it? Okay, so like this much. New paper here. That's totally fine. Now, it would have been simpler if I just graphed it, no? I don't have to use the inbuilt line drawing tools. And it's from 1 to 4 that we're interested in. Therefore, what? Okay, I didn't know that. You can only go from top left to bottom right with this tool. Interesting. All right, so grab this, undo. We didn't use this here, so just do it here. Now, I'm interested in that region right there. Anyway, area of a trapezoid, or trapezium if you like. So it's the quote-unquote height of the trapezoid, which in this case is 3, multiplied by the average length of the parallel sides, which in this case would be 5.5. Right? Okay, that's right. Next. 0 to 5 of the function y equals negative 4x. Now there was something, wasn't there? Oh yes, look at that. Okay, that's nice. All right. So just grab this right here. Make it bigger. And there we go. Nine. 0 to 5, is it? Area of a triangle. So 5 times 20 divided by 2, but it's negative in this case, isn't it? Signed area. Yeah, you agree with me. I like it. For these problems, differentiate each of the following integrals with respect to x. Differentiate. Well, I mean, am I being stupid or something? Because fundamental theorem of calculus, it would just be that there, wouldn't it? But surely the limits play a role. I'm not thinking this through, am I? Okay. So all he did was he just put in the upper limit of the integral. Yeah. Okay. Try to understand it better. Okay. Okay, I understand that. d by dx of the integral of x from x squared to 1. Okay, good. Mm-hmm. Just try, just try, just try. You never know how lucky you can get. So, in this case, the lower limit is a constant and the upper limit is a variable anyway, so it seems okay. So right? Yeah. But now you can't do that. So is it this what you do first? What is it that you do? Don't you do this? Or is that wrong? Just a little bit of the solution. Not all of it, not all of it. Okay, so that goes there. Okay. right? First of all, needs to be the other way around. To comply with the phrasing of the FTC, right? Then let u equal 3x squared du by dx equals 6x. So isn't it like pretty much exactly what I just did before, yeah? Or is it not? And this is another trick. Excuse me. This should be you. And now we do this. And probably cancel. Two over. Let's see. Okay, so we agree about that. But then I sort of dropped a minus there. But otherwise, it's okay. Okay, I like it. All right. Well, you don't scare me. Hang on. Are there any? Yes. Part 2. Big F of x is any antiderivative of f of x. Wasn't there a special case of something? Just go straight into it. Okay. So first, why am I writing out the integral when it's like right there in front of me? For the same reason that I read it out loud. It's to get the hand used to it, the eye used to it, the mouse used to it, to just get used to the fact that this symbol that there is that. So add 1 to the power and then divide by it. Excuse me. Okay. That's part A, actually. B. Evaluate the integral from -3 to 4 of cosine of x minus over x to the 5 dx. By the fundamental theorem of calculus, part 2, we do this. And then we compute. Okay, so for the upper limit, and for the lower limit, it's this. The difference. We get this. And now, compute the definite integral from 1 to 4 of that function we've been working with. So what I will do is just build on what I've already just calculated. Make sense? Oh my goodness me. Okay. This and that. No, not ants. Now this makes me wonder if the previous result is correct. Okay. All right, so see if that's actually right. All right. Good, and I have the plus C. Oh. So I'm a complete and total dummy. Sessions. And it is not. All right. Okay. Fair enough. I was wrong. But for the next one, he doesn't feel the need to actually decimalize it in any way. Strange.